Good evening. I'm Talon and this is Oliver, and we will be representing our team, the Solar Flares. Our project is the Solar Quadcopter. We have designed a new system that will take spherical images, process these images, and display relevant data related to the solar exposure of each unique environment.
Our system consists of a drone-mounted camera, a mobile app, and a web dashboard. The actual drone implementation exceeds the scope of the project, but we have designed the system in a way that it can be easily mounted onto the drone when necessary. Today, we are going to talk about our minimum viable product and general project progress.
Although it is not a part of our minimum viable product, we are creating a mobile app to increase the cohesion and adaptability of the system. It will act as a bridge between the camera, drone hardware, and the website software. The system is started by first turning on the camera and connecting your phone to the wireless network it emits. Before you can start taking photos, the system must be calibrated. In our case, calibration means getting a valid GPS and compass reading. While the GPS reading is taken from the mobile app automatically, in order to calibrate north, you must use the compass feature of the app. And holding the camera over your phone, face the camera due north and take your first picture. This starts your session. From here, you are free to move around, whether with a drone or by hand, and take as many photos as you want using the capture button the mobile application offers. All photos taken are sent over Wi-Fi and stored locally on your mobile device. When a photo comes in, the application will automatically embed EXIF data into the file. Data such as the yaw, pitch, and roll of the camera when the photo was taken. When you have concluded your session, the camera can be turned off and the button pressed on the mobile app, which allows you to upload photos either directly to the web dashboard or via email as a zip file. Although you will be able to choose which of the images you upload, the mobile application will ensure the first calibration image is always selected. We will discuss why later on. This brings us to the website. The opening page is rather simple and has 5 main components: a simple navigation bar, an area to select, preview, and then upload files, an area for data entry such as case name, case description, user login, and archive of users' past cases. User login and archive of past cases are not a part of our MVP, but we intend to have them implemented in our final product. Once implemented, users will be made to log in before data can be uploaded. At this stage, however, the photos for analysis can be uploaded straight away. From here, the selected image is sent to the backend image. The processor first extracts the EXIF data from the first image and then stores its value. It then compares these values to the same data for each subsequent picture and rotates them so that all images face due north. Then, each individual photo is overlaid with a soundtrack graph according to the GPS reading, the yaw, pitch, and roll of the image. The relative sun or shade data of the image is then calculated and then output back to the website. The website then analyzes this data and outputs various graphs and images on the result page. For example, you can see the original photo in panoramic view with the option to rotate the image around. Besides that, you can also view the soundtrack overlaid image in panoramic view. In addition, monthly solar access chart and several other graphs will be displayed to inform the user. They can be easily navigated, and at the top will be a button to download the raw data as a CSV file.
In our opinion, progress on our system is going quite well thus far. The mobile app was not intended as part of our minimum product, as we didn't have the camera with which it would have to integrate. Now that we have a camera, the Ricoh Theta M15, most of our work from now on will be to develop this app.
As we mentioned previously, there are also several other minor features we're yet to implement, so we will also dedicate time to them as well as to our general system cohesion. Finally, as with our last video, we would value any feedback you have and appreciate your time. Thank you.